chapter 20. We're almost done. 2021. Then we're going to start reviews. So, yeah, we're going to be winging that. Please make sure that you have joined teams. We might be doing stuff together for questions, discussions, things like that. I also have to remind out there saying I got about 50% of you. You know who you are who have not done it. Okay, so lecture objectives. Yep, we'll go through those. Remember, the last part was on energy usage that they were stopping off on the new exam schedule. So here's our example of what happened in Sweden. Okay, in 1980, Sweden decided by referendum to phase out nuclear power. This is still one of the conventional forms of energy, nuclear power. Okay, you can go and watch, a ton of debates on nuclear power plants, not nuclear power plants. What's the good? What's the bad? Good and bad for everything. Depends on, what you're going to take. So the nuclear accident at Chernobyl nuclear plant in the Soviet Union sent fallout throughout the atmosphere to Sweden, confirming its decision to, I'm against nuclear power. If you think about all the electric plants that are out there or must be out there on the planet, there have really only been 2 nuclear accidents. I don't know, but when they have an accident, oh boy, it's a biggie. I mean, it's a cluster. So that's why people are not for nuclear, because they remember the accident. But overall, if you think about it, 2 in all those plants that are out there, those are low stats. I mean, some actuary must be very happy with those numbers. Okay, so this was a challenge. What else are they going to do? Here it's showing you a graph. I know, you love them. Developing renewable energy sources took longer than expected, so the plan to close them all by 2010 didn't work out. I mean, we're in 2020. I don't know if Sweden still has some or not, but you can see what they started changing to, okay? Bioenergy, hydropower, down. Look at this, nuclear power, yeah. But look at the reduction of fossil fuels. So, then 2011, Fukushima. So you need to remember the two accidents that happened, okay? You need to remember Chernobyl and you need to remember Fukushima, all right? When they ask you about problems associated with nuclear power plants. On a daily basis, the only thing that they give out that is bad is they give out heat. Usually they put out some thermal energy, as does everything, but here they do it usually into some water source. They do not leak radiation on a daily basis. They do not leak radiation on a daily basis, okay? So in 2015, they announced plans to spend that much money, no one's gonna ask you, to promote wind, solar, hydropower, and bioenergy. Why not? Oh, good. I was hoping the cat would join us because, it was all quiet and everything. So, yeah. Okay, he's leaving. He's going to go in the box, so there might be noise. All right, alternatives to fossil fuel. More than 80% of our energy comes from oil, coal, natural gas, fossil fuels, hence chapter 19, okay? Supplies of these are in decline, and their environmental impacts are driving us to look to alternatives. Yeah, environmental impacts. Bad. Let's find alternatives. So nuclear power plant is not considered really a renewable energy source, so it is an alternative source, okay? They're called conventional alternatives. So hydropower, Niagara Falls was the original electric power plant up there. Biomass energy, bioenergy are considered conventional alternatives to fossil fuel because they're already well established. They have less impact than fossil fuels, but more impact than, say, like solar, wind, geothermal, and ocean power. So here's some more graphs. Oh, look, not only a graph, but a pie chart. It's like a twofer on one page. Conventional alternatives play a much bigger role in electricity generation than other forms. Nuclear and hydro provide about 27%. That's, of the world's electric generation. That's an awful lot. So here are the nations, how much we have, nuclear power capacity, number of reactors. Look, we got the most reactors, 99. I don't know how many of them are still active. Okay, so nuclear power is the use of nuclear energy to generate electricity. And what does it do? It heats up water, which turns to steam, turns a turbine, okay, which generates electricity. It's always the same thing. You have to turn a turbine to generate electricity. So the US has the greatest number, and France is the most dependent. If you just know US has the greatest number, you're good to go. So this is how nuclear energy works. You chemistry peeps already know this. Nuclear energy is the energy that holds together protons and neutrons in the nucleus of the atom. Hence, nuclear for the nucleus. Nuclear reactors are facilities contained within nuclear power plants where thermal energy is used to generate electricity. You heat up something, guess what you're doing? You're turning the turbine. So the reaction that drives the release of nuclear energy inside the nuclear reactor is nuclear fission, splitting apart. You can remember the term fission because you can think of fissures, cracks in the earth, however you want to do it. Okay, inside nuclear reactors, and they have asked in the past, I don't know what they're going to do, what the format's going to be, don't ask me the format for the new test. You can look on AP Central just the same as I can. I've given you 500 things that I've sent out on the College Board website. Okay, nuclear reactors, substance called a moderator, usually water or graphite, will slow down neutrons emitted by fission enough that they will impact other atoms, creating a fission chain reaction. It's like a big, huge game of pool. I've hit this with this much momentum, it breaks apart into this much momentum, they have this much momentum, and they go this way. So if uncontrolled, the fission chain reaction becomes a runaway process of positive feedback, creating the explosive power of a nuclear bomb. For those of you who are taking, I don't know, no, that's not European. Other history? No. What's happening now? Government? I don't know. But these are the reasons that we didn't want some of those countries in the Middle East to have nuclear power plants. They're like, we want to generate electricity. Yes, but how a nuclear power plant, the energy used to run it, that energy can also be used to do what? Make explosive powers of a nuclear bomb, which is why we don't want them and why we want to monitor when they're saying they're creating electricity with the material used. Control rods made of a neutron-absorbing substance can be inserted or removed from the reactor to control the rate of the reaction. Heat from fission is absorbed by water, which is converted to steam that spins a large metal turbine. Then we have to have containment buildings prevent leaks of radioactivity. So this is where our problem usually comes into. What do we do with the waste product? It's bad enough what do we do with the waste from all that coal ash that we're doing, okay? But now we have radioactive waste that we somehow have to store. This seems like not a good plan. It's like we weren't thinking. Well, here's the same picture, okay? And if you look at the picture, this is all contained. Then notice here's water that is cooling this down, which stays circulating, which is different from this water which comes in and cools it off. So they're all, it's like 3 degrees removed from anything that goes into the environment. This is the cooling loop that goes into the cooling tower, and this water is sometimes, for example, exchanged into the ocean or something along those lines to bring back in the cooling water. So it's like, 3 degrees of separation from the radioactive materials. And what are we using? Uranium-235. Do you need to know that? Yes, you need to know uranium-235. Okay. Radioactive isotopes, such as uranium-235, or you could look on this page and here it is. They emit subatomic particles and high-energy radiation as they decay into lighter radioisotopes until they ultimately become something stable. So you learned about this in bio, okay? Just ever so briefly. You can think about it with carbon-14. When you learned about the periodic table, things go through nuclear decay until they become stable. Same concept. The half-life is the amount of time it takes for half of the atoms to give off radioactive decay. Uranium is mined from naturally occurring ore, which must be refined and reprocessed until at least 3% of the sample is uranium. Okay? And telling you, no, you do not need to know 3%. Do you need to know that it's refined? You just can't take crap out of the ground and throw it into a nuclear power plant and have it work? Yes, that's what you need to know. Not how much. So the enriched uranium is formed into pellets of uranium oxide. They're going to ask you uranium oxide. Okay, which are placed into metallic tube. You need to know fuel rods. Okay, fuel rods you need to know are made up of uranium. That's what you got. So researchers from the International Atomic Energy Agency have calculated that nuclear power releases 4 to 150 times fewer emissions than fossil fuel combustion. That seems like a wide range. I mean, couldn't they have narrowed that down for us just a little bit? I mean, just a little something. So the overall lack of air pollution also benefits the health of residents living downwind of the plant. So long as there is no, nuclear explosion or waste or anything like that, living near one, not an issue, because radiation is not oozing out of it on a daily basis. Okay, only if there is un accidente is radiation released. It's happened twice. Only twice. Twice. Drawbacks include the disposal of the radioactive waste and the potential for an accident. That's what the drawbacks are, basically, for the potential and the disposal. That's what you need to know as the drawbacks for nuclear power plants. All right? They're not giving off, the only greenhouse gases that are being emitted are basically in the making of the plant. Building the plant itself, transporting stuff to and from it, that's where we're using some type of fossil fuels. So, given these advantages and drawbacks, many governments see nuclear power as an improvement over coal-generated electricity, or they're using it as an excuse. We don't know what, Iran, Iraq, I don't know who's, Afghanistan, I don't know who's, wants to get on the nuclear power plant, bandwagon. But then we were saying no because we didn't trust them not to make nuclear bombs. Then we were going to oversee it, but then they're not letting us oversee it. Look at that. Daily life. So much fun. Risks and impact of coal-fired versus nuclear power plants. Okay? You guys can pause and read it yourself. I have faith in you. Ooh, here, for each type of impact, more severe impact is highlighted in red. Radioactive waste, bad. Oh, look, I like that picture. Nuclear fusion, we have not figured that out yet on this planet. Forces together the small nuclei of lightweight elements and under extreme high temperature and pressure. Fusion requires temperatures of millions of degrees. And so far, experiments have required more input of energy that is gained from the reaction. You know where fusion works well? The sun. The sun does fusion. The sun is hot. So we cannot contain the energy that the sun makes here on this planet. That's why you hear people experimenting, or maybe you don't, because, I know you guys don't watch the same things I do, but you hear about them trying to do stuff with, quote unquote, cold fusion. Okay? Because regular fusion is hot like the sun hot, because that's how the sun is made. Okay? So nuclear power plants pose small risks of large accidents. Large accidents. So in 3 Mile Island, I was like, what? Didn't you just say there were only 2 major accidents? 3 Mile Island experienced it, but it stayed contained. It didn't get released out. So, experienced an accident due to human error and mechanical failure led to drainage of water from the reactor vessel. This caused a meltdown where the fuel rods melted and began releasing high amounts of radiation. And if you look, 3 Mile Island was considered a near miss because the fuel rods did not completely melt down and the radiation was contained. See, I wasn't making it up. I remembered. Okay. Chernobyl, that was a big oops. An explosion at Chernobyl power plant in Ukraine. What, is there still a Ukraine? Is it called something else? I don't know. Caused radioactive debris to enter the atmosphere for 10 days. And it was a big, it was not good. It was not good. Because, at that time, it was, the USSR in 86? Yeah. So, they kind of kept all that new stuff and they didn't tell the people what was going on until people started dropping and, birth defects and things like that. So, on top of that, guess what happened? I don't know if you know, but the atmosphere. Tragedy of the commons, right? We're all interconnected on this planet. So atmospheric currents carried radioactive fallout from Chernobyl across much of northern hemisphere, particularly the Ukraine, Belarus, and parts of Russia and Europe. That's what they're called now, because we know the wall didn't come down until like the 90s. So here's the containment dome under construction, okay? A hastily built concrete and steel sarcophagus is to be replaced by a larger confinement structure to prevent any further radiation leaks. And when they had people building the original ones, these people knew going in there and making this, they were saving thousands of lives, but they were going to die. And they did. The people that constructed the original concrete around it, they all died from some type of radiation poisoning and stuff like that. So then here we had the problem was they're often near water sources for the coolants to come in. Well, when you keep your batteries down low here, your battery backup, and they get swished away, that becomes an issue. So in 2011, an earthquake struck, making a tsunami come, and at the Fukushima nuclear power plant, the earthquake shut down power, and the tsunami flooded the backup generators. So it was a twofer there, okay? So I know places learned from this, because Port St. Lucie has a nuclear power plant, and after this happened, they moved all of their battery backups up to the top instead of being in the basement. Because if there's any type of flooding, you still kind of want it to be working. All right. Radioactivity was released during and after these events at levels about 1/10 of those from Chernobyl. So they had enough backup that it wasn't the cluster boo-boo that Chernobyl was, and they were more forthcoming, and they got people out of there, and they did more proactivity of trying to get people out of the area. And it was done quickly, unlike 10 days later with Chernobyl, where at first they were like, no, you're fine, it's good. Maybe, you want to move, maybe you want to get out. So that's what Chernobyl, here they were like, everybody, let's go, let's get out. Sirens, move it along. So there's cat on a chair. So much of the radiation spread by air or water into the Pacific Ocean, and the trace amounts were detected around the world. Okay? But look, at most of it was over the ocean. Not that that's good, but once again, we do like to have things surrounded by people because we are egocentric. So long-term health effects on this contamination are unknown. They shut down 50 of the nation's nuclear reactors. They actually did something, or they're like, oops, boo-boo, everyone, until we check everything out. So smaller scale incidents have occurred at nuclear power plants worldwide, but safety measures have prevented meltdowns. So there are safety measures in place, and there are huge proponents for nuclear power plants out there. Another concern is that the radioactive material could be stolen from plants and used in terrorist attacks. That would be bad. Okay? Reducing nuclear weapons stockpiles has also been a priority, with the US and Russia processing and transferring about 500 metric tons of highly enriched uranium into use at nuclear power plants. Look at us. Instead of reduce, we're reusing, right? It's not recycling, it's the same thing. We're reusing. So here's where our problem is. What do you do with these rods when they're done? They're still radioactive, so waste disposal remains a challenge. Yes, it does. Half-lives of the leftover radioisotopes from fission reaction is upward of hundreds of millions of years. Man, imagine getting that contract in order to sort. Yeah, 100 million years, could you watch these things, make sure that they, stay underwater and they're contained, and you monitor them every day? That's a contract to have. Okay, currently nuclear waste from power generation is being stored in pools, wet storage, cooling ponds, or thick casts of steel, lead, and concrete, dry storage. Look, he has to stay walking in the green path. I don't know what happens. Is it like, does he wear a collar like the dog thing if it goes over? So you don't get too close? I don't know. I don't want that job. I sure don't want that job. Turkey Point, down in Miami. Port St. Lucie, St. Lucie County. Spent fuel rods and low-level waste is currently stored in more than 120 sites across 39 states. Nuclear waste managers would prefer, for security purposes, to store the waste in a single location. Well, yeah, that's good in theory. except, you know, how do we get it? Where are we storing it? Like, you know, how do we transport it from here? Is it by truck? What happens to do we put it on a plane? So we don't have a really good plan. We didn't think this whole thing through, is what, I know you guys are surprised. But we did not think it through. It's like, oh, we have to store it for, you know, a couple million years. And whose thought process was that? Okay, so Sweden selected, okay, the Forsmark power plant site for its central location and plans to store high-level waste in copper canister buried underground bedrock. Why do we keep thinking shoving stuff in the Earth's crust is a good plan? I don't know. I don't know. The U.S. had a similar facility planned in the Yucca Mountain in Nevada, but it didn't work well, okay? Protests put an end to those plans because if you go back to the picture, okay, Nevada, look, I'm looking. Look, so say we had stuff in Florida, we'd have to transport the spent rods here. That looks far to me to get it from here to there, okay? Since the 80s, nuclear power growth has slowed, okay? Public anxiety from Chernobyl and Fukushima has made utilities less willing to invest in it because someone's got to invest in it. So building plants is enormously expensive. On the front end, a lot of money. Plants have aged more quickly than expected, with plants shut down only about half of their expected lifespan. And then you have to decommission them, which means you have to do all that stuff with that radioactive waste. Nuclear power is still one of few currently viable alternatives to fossil fuel. I don't know. I still like solar. I don't know. I'm silly like that. Here's how it works. Okay. Hopefully without making the noise. Okay. You get that. Oh, there's the answer. Oh, more. Sorry. Okay. Bioenergy is derived from biomass. Prefix bio means living. Okay, so biomass consists of organic material derived from living or recently living organisms, and it contains chemical energy that originated with sunlight and photosynthesis. In principle, it's renewable and releases no net carbon dioxide into the atmosphere. Any carbon released has been absorbed in the production of the biomass. So here are some different ways for biomass. Some are better than others. So we harness bioenergy from many types of plant matter, including wood from trees, charcoal, crop residue, as well as combustible animal waste. So in other words, if you're burning cow poop, okay, or if you live on the steppe in Mongolia, you're taking yak poop as your source of fuel. So you can see all of these things. And here we have biofuels that we've been looking at. And the problem is, like with so many things, corn, when we grow crops for something besides consumption, you can see where that goes. We still have to harvest it. We still have to cut it down. We still have to process it. So, you know, there's still fossil fuels involved in this. That person not making a big, huge dent. So in rural regions, developing countries, people heavily depend on fuel wood to burn. Okay, this can lead to deforestation. We know that's what's happening in South America. The government says no, but if your nearest neighbor is 20 miles away, who's going to know if you cut down some trees and you burn them? Okay. Also, if you have big conglomerates that go in there and don't tell anyone and you got a lot of forest, that happens too. So once you have deforestation, you have soil erosion and desertification. In developed countries, sources of bioenergy are used to produce biopower, generating heat and electricity. And then you have liquid biofuels may also be generated from bioenergy. So just look at the names. You know what it means. You can pick that out on multiple choice. I have faith in you. Okay? We use it to generate electricity. Waste products from logging, sawmills, pulp mills, paper mills can be used as a source of biofuels because it's all like, you know, a fireplace type concept. I know we don't have those in Florida. That's where you put wood and it generates heat. Okay. So another source is biogas from anaerobic bacterial breakdown of waste in landfills. So if you drive by the landfill and you see plastic pipes coming up, it's releasing methane gas from the anaerobic breakdown because there's no oxygen in there. So it's not like your compost pile that gets oxygenated. It's still breaking down, but it's being broken down through anaerobic ways using anaerobic bacteria, and they give off gases that can then be burned. So there you go, waste product, conversion facilities, output, final product, okay? Of a biogas plant in Swedish city of, no one's gonna ask you the name of the Swedish city, thank goodness. No, you gotta spell it, just kidding. Taken from forestry waste, crop waste, garbage, and food waste. So now if we're using it for, say we're burning our garbage and we're capturing it, I mean, it's not the best solution, but it is a preferable solution instead of burying our waste. So certain types of plants, I don't know what fescue is or switchgrass, but you know, grow quickly enough so they can be cultivated specifically for engineering biopower. It can be combusted directly to generate electricity or mixed with coal in a process called co-firing. Okay? So biopower is cleaner, contributes less to climate change, and is generally more sustainable. But every time you burn any type of fossil fuel, you're still releasing stuff into the atmosphere. You're weighing, you know, good versus bad, and you've got to make educated decisions on that. So corn grown for ethanol, if you go and look at the gas that you're putting in your car, it contains a certain percentage of ethanol. It's produced by fermenting biomass, generally from carbohydrate-rich crops, corn, in a process similar to brewing beer. Hey now, what happens if you brew your own beer after you're 21, because it's wrong unless you're in the middle of the ocean or another country. You're brewing your own beer, and then the offshoot you could somehow or another manage to put in your own car? Someone get on that. Go get a job, okay? Ethanol is now widely added to gasoline to reduce automotive emissions. Corn isn't in the United States. Look at that. Could you imagine that? Someone figured that out. Home brewing beer, then using the off product to fire up your car? Go do that. Once you're 21. Because before it would be wrong. Okay, so then you have flexible fuel vehicles, and you can see them on the outside. They actually say flex fuel. Operate at a mix of 85% ethanol and 15% gas, popular in Brazil, which generates ethanol by fermenting crushed sugar cane. Look at that, it makes sense. And here's our nice little graph again. Rest of the world, Brazil, the United States. We're not doing bad on that. Corn, where do we grow corn? This is how much we grow, area that we would need if we wanted to switch over. Growing corn to produce ethanol intensifies pesticide use, because anytime you grow something, if you're growing it in a big, huge industrial agriculture, as we know, you have to use fertilizers, you got to use pesticides because you're growing the same crop in the same place, so all the pests are going to come in. Then what do? We get on the insecticide treadmill. You see how that works. Fertilizer, we have fertilizer runoff, okay? Freshwater depletion, because then you have to water it. Energy use and other impacts of industrialized agriculture. Industrialized agriculture. So now this has become industrialized agriculture, which we know isn't the greatest. Significant land is also required to replace the automotive fuel used in the U.S. With ethanol from corn, the nation would need to expand its corn acreage by more than 4 times. I don't know, can we do it in like, are there people in the Dakotas? I don't know how that works. Then we have this biodiesel, and this is just funny. A fuel produced from vegetable oil, used cooking grease, or animal fat. Less vehicle emissions, identical fuel economy, cost-effective, non-toxic, can be sourced from food waste. So these people go around, they do this in California a lot, okay? I'm going to say a lot as in compared to any place else, where they go and collect the oil from any place that has a fryer, okay? Any place that has a fryer. So these restaurants have to pay to have it disposed of. These organizations take it and they convert it and they use it as biofuel. And then you're just behind a car that smells like chicken wings. I mean, that's not bad, except then you want chicken wings. And that does happen. So, novel biofuels are being developed, I'm sure, all the time. Look at that. Powered by biofuel. Sustainable jet fuel. Many species of algae are being cultivated to produce biodiesel, ethanol, or even jet fuel. Hey, algae grows mighty quick. It can be grown at a large scale, outdoor ponds, closed tanks, closed transparent tubes called photobioreactors. Guess what that means? Photobioreactors. You think on that while I pause and upload a new one.